To set the end play of the cam, first we have to install our cover with the gasket and torque it down to final spec. Next, we're going to install our dial indicator either on the back of the block, against the back of the cam, or as we've done, through a front oil return in the front of the block against the back of the cam gear. To check your final clearance, all you need to do is gently pry on a cam lobe and read the dial indicator. As you notice, we've arrived at 5 thousandths end play on our cam, which is desirable. Earlier we mentioned that some piston sets for the small block Chevys come in sets of 4 left and 4 right hand pistons. This becomes very evident when we take a look at number 1 and number 3 cylinder. Take note that the larger intake valve relief are next to each other on 1 and 3. Always make sure that you take special note, if you do have a piston set of this nature, to make sure that your intake and exhaust relief are in a proper location to location of the valves in the head. When we attempted to install our windage tray, we ran into 2 problems. First was caused by the fact that, to our knowledge, General Motors never designed a windage tray for the 400. Due to the fact that the main bolts on the 400 are spaced wider apart than all the small blocks, we found that we needed to slightly elongate the mounting holes to accommodate the width of the studs. The second problem we ran into was the fact that when we installed our ARP main studs, as they recommended, it brought the height of them down too low to the center of the crank. What we had to do was loosen the attaching nuts, back off the stud, and raise it in height approximately 1/8 of an inch. We measured this distance for you. If you install the studs that carry the windage tray to a height from the main cap to the top of the stud of 1 13/16 inch, and put the bottom nut that goes under the tray at a height of 1/4 of an inch from the top of the stud, we believe you'll find that the tray will mount properly, giving you adequate thread on top for the bottom nut, and also give you adequate clearance between the connecting rods and the underside of the tray. Before we set the actual pickup height, we want to first inspect the clearance between the rear main stud and the pump body, and the rear counterweight and the pump body. There should be an absolute minimum clearance of 30 thousandths between any of these components and the pump body. If you do not have this amount of clearance to the counterweight, you must remove the pump and grind that area of the pump body away until you've arrived at adequate clearance. With the rear bolt, what you should do is remove the stud and grind away the excess portion of the top of the stud and not remove metal from the pump body. Once we have determined that we have adequate clearance between the counterweight, the rear main stud, and the pump body, we'll set our pickup height. It's very simple to do that. Going to do is grab the pickup and pivot it upward away from the crankshaft quite a bit. Taking our oil pan with no gasket on the block, we place the pan on top and press down, moving the pump pickup down until the pan seats flush against the block. Remove the pan carefully so we don't disrupt the position the pickup's in at this time. Measure from the front lip of the pickup down to the windage tray, and now we're going to move the pickup 1/4 inch closer to the tray. This will be our permanent installed height of the pickup. All that needs to be done now is remove the oil pump from the block, remove the bottom cover of the pump, and we're going to full braze the oil pickup tube into the pump body. This is how your pickup tube and oil pump should look like after full brazing the tube to the pump body. Notice there is a full fillet of brass all the way around the tube to the pump body. This ensures us of 2 things. One, that the pickup cannot pivot in the hole and alter its height to the bottom of the pan or fall out. And 2, that we have sealed the entire tube to the body so that no air can be drawn in instead of oil being picked up from the pickup. Also, we extended the brass coverage to include an area of the end plug of the bypass relief shuttle housing to ensure that this plug can never come loose. Also, it's a little hard to see, but in this area of the pump, there is a small expansion plug that's been driven into the housing, which seals a drill passage that runs from the suction side of the bottom plate into the relief chamber. We've never seen one of these plugs come loose, but we never want to see it come loose on our engine. The oil pump drive shaft has a reduced dimension through this area. It is a drive shaft of this type that must be used with a 400. Also, always use a pump shaft that has a pinned metal sleeve where it couples to the shaft of the oil pump. Also, drill a 5/32 hole through the top of the head of the oil pump attaching bolt so you can safety wire it after torquing it to 30 pounds with anti-seize on the threads. Once this assembly has been installed, you should rotate the crankshaft and double check your rotating mass clearances to the windage tray and adjust as necessary. The small block Chevrolet 400 engine is different from all other Chevrolet small block engines in that it is externally and not internally balanced. In order to externally balance the engine, the harmonic balancer is offset in mass. Please note that on the back side of the 400 harmonic balancer, the inertia ring is not consistent thickness. Also, on the flywheel, they've added a counterweight to finish the total mass balancing of the crankshaft assembly. If this inertia ring changes position from the hub, your engine will be out of balance. To ensure that this doesn't happen, we can modify the balancer, pinning it in 3 locations to assure us that it does not slip and knock us out of balance, however, still allowing it to absorb torsional vibrations in the engine. To properly pin the 400 balancer, first we have to divide the circumference in 3 equal 120-degree spaced sections. Next, we're going to drill a 1/4 inch hole centered in the width of the inertia ring directly through the ID. Next, we're going to thread this hole for a 5/16 18 thread and counterbore the top of the hole. After which, we're going to use a 1/4 inch Woodruff key cutter to construct a slot underneath the hole we've drilled and threaded. Next, we're going to take 3 5/16 18 countersunk machine screws, and we're going to reduce the threads on the end of the bolt down to the base diameter of 250 thousandths, 1/4 inch. This 1/4 inch diameter section will be extended through where we used the Woodruff cutter. Once these bolts are installed with Loctite and torqued to approximately 18 foot-pounds, they will assure us that the inertia ring cannot lose its location with the mounting hub and will assure us that our engine will stay in proper balance and that our inertia ring will show us proper timing on our timing pointer at all times. For detailed instructions, drawing, and dimension of this entire procedure, we'll refer you to the Chevrolet Power Service Manual, which can be purchased at any General Motors dealer. And if you look up into the small block Chevy section, you'll find an entire accurate blueprint and instructions of how this operation is properly done. Before attaching the cylinder heads, there are 2 things we want to do. First, we want to reestablish true top dead center #1 cylinder using the same methods we use when degreeing the cam, with a dial indicator and a degree wheel. We've already established top dead center #1 and removed the degree wheel. Now what we want to do is align our timing pointer with 0 on our balancer. This is our timing reference mark for later. You have some options here. We've opted just to use the factory scale and the 0 line of the balancer. Another option would be to get a timing tape and attach it around the balancer, which gives you extended integers on your timing scale, or purchase a balancer that has the integers stamped directly into it. For our money, we'd rather buy a good adjustable timing light because it'll be much more useful than just a timing tape or a degreed balancer. Next, we're going to check our piston and valve clearance before permanently attaching the cylinder head. The necessary items in checking piston and valve clearance are going to be a used head gasket of the same type that you're going to use in the engine, or shim stock, which is the same thickness as the compressed thickness of the gasket you intend to use. Also, we're going to need 2 push rods, 2 rocker arms. We're going to use 2 solid lifters. We need to use solid lifters because if we use a hydraulic lifter, we'll get inaccurate readings. We need several head bolts and some modeling clay. We're going to take some modeling clay. We're going to put it on top of the piston in the valve reliefs so that extends just slightly beyond the top surface of the piston. This is the area that will run closest to the valve. We're going to attach the head using 4 bolts that surround the cylinder we're going to check, which is cylinder number 1. These bolts need only be tightened to about 10 foot-pounds. We're going to adjust the valves to 0 lash to simulate the 0 lash that we'll have on our hydraulic lifters that we're going to run in this engine. All we have to do now is rotate the crank 2 full revolutions. So we go through our intake and exhaust cycles. Now we need to remove the cylinder head, remove the clay from the top of the pistons, and with our mic measure the thinnest section of the clay. This will give us our piston and valve clearance. With the head removed, we're going to take our shim stock and gently pry off the clay from the piston so as not to distort it, and take our caliper and measure the thinnest section of it. This will give us our actual piston and valve clearance, and we have 250 thousandths. We have a 1/4 inch of piston and valve clearance, which is very generous. Rule of thumb is you want no less than 80 on the intake and 100 thousandths on the exhaust valve to have bulletproof clearances. Let's take a very close look at correct rocker arm geometry. For rocker arm geometry to be correct, the tip of the rocker arm should be contacting the center of the diameter of the valve stem at half valve lift. Right now, we're at 0 valve lift, and if you notice, the tip is contacting the valve stem off center in the direction of the rocker arm. I'm going to rotate the crankshaft very slowly and keep a close eye on the contact point between the tip and the valve stem. I'm going to stop at half lift, and you notice that the contact is almost dead at the center of the valve stem. Then I'll continue rotation till we achieve full lift, and you notice that the tip is moved to this side of the valve stem, almost the same of the amount off center it is now. Once again, we're rotating the engine in running rotation. We're approaching half lift now, and we're going to stop at half lift and take a close look. You'll notice that we're almost dead at the center of the width of the valve stem. Continuing rotation till full valve lift. You notice it's moving off center further away from the rocker arm. And now at full valve lift, you notice it has moved almost the same distance off center away from the rocker arm as it was off center when we started from 0 lift. If at half lift you notice that the tip is still closer to the rocker arm than it is to the center of the valve stem, you need to install a longer push rod. Consequently, if the tip has gone beyond half of the width of the valve stem, away from the rocker arm body at half lift, you need to install a shorter valve stem to achieve optimum rocker arm geometry. Here's an example of a properly fitted and installed baffle. Notice it fits tightly along the sides of the lifter valley. fits snug to the front and back, and as I mentioned earlier, we trimmed away this entire corner to open up access to the oil return in the back of the block. Also at this time, it's a good idea to check that all your push rods clear the baffle and don't touch it. It's also good practice to rotate the engine through 2 full revolutions of crankshaft rotation and watch the push rods to make sure that they continue to clear during operation. When the baffle is properly installed, you'll notice that it can't rock side to side or front to back. These 2 pieces of flat spring steel are mounted with the supplied hardware, and as the intake manifold is bolted in place, push down on the top to retain the baffle tray in its proper location. With the valves adjusted, now all that's left is to install the intake manifold, carburetor, distributor, fuel pump, and other external accessories. If at this time you are unfamiliar with proper reassembly procedures, we'd like to draw your attention to our original tape, Rebuilding Your Engine, American Muscle Cars, Volume Number 1. In this tape, we go through intimate detail, bolt by bolt, disassembly, inspection, reassembly of the entire engine, along with tips on how to better build your engine and make it a stronger unit, plus how to check the machine shop's work to see if it's correct, and how to easily measure all critical tolerance and clearances using economical equipment. Now, it's on to the dyno.